Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello students, welcome again to the TV learning program. This is Teacher Pasco. Today I will be with Senior 1 students and we are continuing with unit number 5, but because, as you know, we have covered a lot in this unit, today we will focus on the exercises. So today's lesson is the exercise which will look at all the parts of this unit we have already covered. Because we are doing a kind of revision, but a revision which is in the form of an exercise, I've compiled all of the objectives we have from the lessons we have covered so that we can know or they can help us to make a self-evaluation. So at the end of this lesson, you should be able to define the terms atom, element, molecule, atomic number, mass number, and many more definitions or many more terms. You should also be able to state the properties of subatomic particles. As you can see, we have discussed all of this. And number 3, you should be able to write the symbols of different chemical elements. And number 4, you determine the number of protons, neutrons, number of electrons from atomic numbers and mass numbers. You know, from the atomic number and the mass number, we can determine the number of protons, number of electrons, or number of neutrons. We know the simple calculations we use. And next objective, we should be able to represent atoms of a given element by the symbol, and the symbol which shows the chemical symbol of the element containing the atomic mass as well as the atomic number and the mass number. And if you remember well, we also studied the electronic configuration. And the electronic configuration we studied, we did that in two forms. So you should also be able, at the end of this lesson, to represent the distribution of electrons in the atom using a diagram or simply using the numbers showing how many electrons we have in each of the energy levels occupied. And we have part 1, the definitions. The definitions we are going to define, and before I give you the answers, I want you to take the notebooks or the exercise books. You take a pen, and why do we have to do that? It's because you will try the exercise first. And after that, I will give you the answer. But some of the numbers will be left to you to be done as the homework. So in today's session, you will not have a distinct slide of the homework. So what we will do is to leave some questions on each part, as we will have 6 parts in this exercise, and each part will have some questions left, and those questions, you will try them as an exercise. So every time we will have to write those numbers, and you will try them as a homework. Now, definition number 1. What is meant by atom? What is an atom? How did we define an atom? Number 2, what is mass number? And number 3, what do you understand by the term isotopes? Those are the 3 terms we are going to define, and the 3 remaining elements, atomic number, and molecules will be done as a homework. You have some seconds to think about the 3 definitions. Hurry up, please. Okay, so let us have the answer for the first definition. What is an atom? We defined an atom as the simplest particle of an element, or the simplest particle of matter, which can exist on its own and which will retain the properties of an element. I repeat, an atom is the simplest particle of matter which can exist on its own and which retains the properties of an element. That is the atom. What is mass number? Think about it, please. What is mass number? How did we define mass number? Mass number, we defined the mass number as the sum of protons and neutrons. Do you remember where in the atom we find those two particles? Yes, we find them in the nucleus. So the sum of protons and neutrons found in the nucleus of a given atom is called the mass number. So mass number is equal to the sum of protons and neutrons in the nucleus of a given atom. Okay? So we go to the next. And what are isotopes? How did we define the term isotopes? We have seen that atoms of a given element may be different, but they should always have the same number of protons. But what we have seen that can be different is the number of neutrons. So from there we can define isotopes. And isotopes are atoms of the same element which have different mass numbers. And here I explain they have different mass numbers. Why? Because the number of protons is the same, but they have different number of neutrons. So for two atoms, if they have same number of protons and different mass numbers, it means that the number of neutrons will be different. And that is the reason why they have different mass numbers. Good. So please note down the 3-element atomic number and molecule definitions that you will try as a homework. And then quickly we go to the next slide. Thank you very much. So let's go to the next slide. Remember, we have seen that we defined an atom as the smallest particle of matter. But we have seen that an atom is also composed by subatomic particles, the particles which are smaller than the atom itself. And we have found that there exist 3 main subatomic particles. Do you remember them? The subatomic particles. I hope you do remember them. So here we have a table to be completed. And I will give you one particle and its properties, and the 2 remaining particles, you will name them and give their respective properties. So I give you the first particle with its respective properties. You try the second one, and I give you the answers. And for the third one, you will complete it, and give the respective properties. Number one, let me give you the protons. 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 Do you remember the location of these protons? Where do we find them in the atom? You will tell me that later. Let me give you time to think about it. But I'm very sure you remember the mass of this proton, the relative mass of this proton. The relative mass is 1. Relative mass is 1. And what is the charge? What is the charge of this proton, please? The charge is positive 1. And where do we find it in the atom? We find it in the nucleus. In the nucleus. Okay? We find it in the nucleus. And what is the next particle? But the particle I want, don't tell me, because we have seen that in the nucleus we have 2 particles. So let us say the other particle, which is not found in the nucleus, and the remaining particle, which is also found in the nucleus, it will be done as your homework. So the other particle is, good, the electron. Electron. And what is the relative mass of the electron? The relative mass of the electron is approximately 0, because it is 1 over 1,840. So this is very small, and we consider it to be almost equal to 0. And what is the charge? -1, and its location, it is located on the electronic shells. The electronic shells. So that is the other particle we do not find in the nucleus, but which is found in the electronic shells, and I mean around the nucleus. And 1 particle is remaining. You will write it down and you give the properties of that particle. That will be your homework. So let's go to the next slide. The next slide, we have the chemical symbols. So we are going to go back and see how we represent chemical elements. We have 2 parts on the slide, and the first part is to write the chemical symbol from the name, and the second part, you will deduce the name from the chemical symbol. So we have hydrogen. What is the chemical symbol of hydrogen? Don't look on your periodic tables, please. Don't use them. You have to test yourself. Check if you have understood everything. So don't use your periodic table for this question. What is the chemical symbol for hydrogen? For hydrogen, the chemical symbol is this one. H. And what is the chemical symbol for potassium? Don't say it is P. It's not. P is for phosphorus. Potassium, it is K. As we have seen that some of the elements will have their chemical symbols derived from the names which are in other languages, like the Greek or the Latin. So that K comes from kalium. You remember that, kalium. And Next, you will try to give the chemical symbols of silver, copper, and silicon. Silver, copper, and silicon. Note them down, please. Those are the names, and your work is to give their chemical symbols. You should always try to do it on your own and don't copy from the periodic table. I'm very sure you have your periodic tables, but if you have to train, don't look from there. It's not good. And we go to the next part. From the chemical symbol, we deduce the name. We have Na. Na. What is the name of that element? Na. That one is sodium. Sodium, and just like potassium, it comes from natrium. Natrium. That is why we have Na. And number 2, we have P. P. What is the name of that element? The name is potassium. No. It's phosphorus. Phosphorus. And the 3 other elements we have is Au, I, and Mg. So you will deduce the names of those 3 elements from their chemical symbols. Au, I, and Mg. Note them down, please. And we go to the next slide. Next slide, we have to find the atomic number, the mass number. We determine the number of protons, number of electrons, number of neutrons, or we represent the chemical symbol. And what we will use here is the table. You see the table we have here. On the table we have here, we have the particle, the atomic number, mass number, proton number, neutron number, and electron number. And the first particle we have, and that is the row I'm going to complete for you, and you will try the other rows. It is aluminium with 2713. How do we determine the atomic number? We know that the atomic number is equal to the number of protons. But if we have a symbol like this one, what is the position of the atomic number? Here we have the atomic number. This 13. Remember, the elements, we represent them like this. It is always A, X, Z. The alphabetical order. We start with A, we go to X, and you know the one to go next after X will be Z in the 3 we have. So it is always A, X, Z. A is mass number, and Z here is the atomic number. And here, X is the chemical symbol. So from this question, this element, aluminium, the atomic number will be 13. 13 here. We have 13. Atomic number for aluminium, atomic number is 13. And the mass number that is next, it is 27. So it is 27. Very simple. And now we have to determine the number of protons. And we know that the atomic number is equal to the number of protons. So number of protons will also be 13. In a given element, or an atom of a given element, we know that the number of protons is equal to the number of electrons. So number of electrons we have 13. How do we get the neutrons? the neutrons, please. We know that the mass number, which is 27, it is equal to the sum of protons and neutrons. So having the number of protons and the mass number, we can get the number of neutrons. That will be A minus Z and 27 minus 13, which gives 14. So we have 14 neutrons. And as I said, you will try the 3 next. So please take note of the remaining part of our table. And you will do that as a homework. Well, let's go to the next. Now, let's see how we write the electronic configuration. How do we write the electronic configuration? Do you remember that? And what is the purpose of writing electronic configurations? The main purpose of writing the electronic configurations is to show how electrons are distributed in different energy levels or electronic shells in the atom. We've seen that electrons are located in the energy levels or the electronic shells around the nucleus. But we know that the energy level, all energy levels we have in the atom, will not accommodate the same number of electrons. And we know that the first energy level, which is K, can only have 2 electrons. L, which is the second, can have 8. M, which is the third, can have 18. And N can have 32, and so on. You remember the formula we use. And write the electronic configuration of the following elements. We will try 2 elements only: sodium and calcium. And let me ask you one question. What do you think we need to know which has not been given on the slide here, but that we can identify from the periodic table? The main thing we need to know so that we can write the electronic configuration. The electronic configuration means the distribution of electrons. So we should know the number of electrons. How do we determine the number of electrons? Remember, from the previous exercise, we have seen that if you know the atomic number, you also know the number of protons. If you know the number of protons, you also know the number of electrons. So we can determine the number of electrons from the atomic number. Take your periodic tables, please, and identify the atomic number of sodium. Atomic number of sodium. The atomic number of sodium is, for sodium, it is 11. The atomic number. And the next element is calcium. What is the atomic number of calcium? It's 20. Now let us write the electronic configuration. We've seen that the first energy level will contain how many electrons? 2 electrons, a maximum of 2 electrons. And after the first energy level is full, we go to the next, which can contain a maximum of 8. Now we have 10 electrons, and 1 is remaining, which will go in the third energy level. And for calcium, we have 2 electrons in the first energy level, 8 in the second energy level, and 8, remember, for calcium and potassium, we have seen that there is an exception. There is an exception before we feel the third energy level. We have to make sure that we put 2 electrons in the fourth energy level. And because of that, in the third energy level, we are not going to have 18 electrons. And instead, we get 8, and then the remaining electrons will go in the fourth energy level. Now we have 20 electrons. Okay? So we have 3 more atoms. You are going to write the electronic configurations. Remember, you first determine the number of electrons that can be deduced from the atomic numbers, and then you write the distribution in different energy levels. It will always depend on the number of electrons available. So it's not a must that every energy level must be full. And the last part of our exercise is to draw the diagrams to show the electron distribution. We have 2 methods. We can use the numbers or use diagrams. Now we have fluorine and argon. For fluorine, it's this one. The first circle represents the nucleus, and the second represents the first energy level. What is the atomic number of fluorine? From your periodic table, it's 9. So in the first energy level, we have 2 electrons. And after using 2 electrons, 7 will be remaining, and the 7 will go in the second energy level. 1, 2, 3, 4, 5, 6, and 7. So we are done with fluorine. That is how we represent fluorine. And the other one is argon. What is the atomic number for argon? It's 18. So we have argon here. The first, this is the nucleus. The second represents the first energy level. And the third represents energy level number 2, which contains a maximum of 8 electrons. And this one is the outer energy level, which will also have 8 electrons to complete 18. And we are done. We are done. And as I said, the remaining questions will be done as a homework. So let me thank you very much for your attention and hope to see you next time. Stay safe.